Hello, welcome to Chapter 2, Section 6. Sorry you can't see me this time. I left my camera at school, so unfortunately you don't get to see me tonight. So this is Chapter 2, Section 6, the rational root theorem. Okay, that's the main topic of this particular chapter, and that's the only thing we're going to talk about using this rational root theorem. And what this rational root theorem does, it helps us find all of our zeros, no matter if they're real or imaginary. Okay, so we're going to find all zeros, capital All, of a function using rational root theorem. So we're going to mind our P's and Q's. That's a little trick to remember how to do the rational root theorem. Okay, so the rational root theorem, what it says is it is a method that helps us find all possible roots of a polynomial equation, real and imaginary. Okay, so we're going to find the real and imaginary roots using the rational root theorem. Okay, now part one is kind of easy. All it's going to do is help us find what are the possible real roots. Not all of them, just what are the possible real roots. Okay, so what we're going to do is we're going to find our P's and we're going to find our Q's. Okay, how do we do that? Our P's are all of the factors of our constant term. So what numbers go into 8 evenly? Okay, 1 goes into 8 evenly. 2 goes in 8 evenly, 4 goes in 8 evenly, and 8. Okay, hopefully you're thinking, well, there are more. Okay, not only are positive 1, 2, 4, and 8 factors of 8, but the negatives are also. So plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Those are all of our factors of our P, which is our constant term, the number at the very end. Q are the factors of our front or our leading coefficient. So what are the factors of 2? Factors of 2 are 1 and 2, and the negatives of 1 and 2. Okay, now, those numbers just help us come up with our possibles. Our possibles are actually our P's divided by our Q's. Okay, so what we're going to do is we're going to take our P's and we're going to divide them by our Q's, and those are our actual possible real roots. Okay, so let's start with our P. First P. 1 divided by 1 is 1. 2 divided by 1 is 2. 4 divided by 1 is 4. 8 divided by 1 is 8. Okay, so that means our 1 is done now. Then we go to our 2. 1 divided by 2 is 1/2. 2 divided by 2 is 1. We don't need to add that again. 4 divided by 2 is 2. We don't need to add that again. 4 divided by 2 is 2. And 8 divided by 2 is 4. Okay, so that is it. These are all of our possible real roots. Possible real roots. Now, the word possible means not all of these will work. These are not all of our x-intercepts on our graph. These are the only ones that are actually possible. Okay, there are no other whole numbers that would work for this particular example. These are the only ones that are possible. Okay, so let's try another example. It says find the possible real roots. So when it's possible, all you're doing is finding your P's and Q's. Okay, so let's do it again. Our P's, our Q's. Now, this equation, we have to rearrange it. So I'm going to do 3x to the third plus 8x squared. How do I get a positive 9x on the left? I subtract it. And how do I get a negative 2 on the left? I add it. Okay, so now I'm no longer going to use this one. I'm going to use this equation right here. All right, so our P's are all of the factors of our constant. So what are the factors of 2? 1 and 2. Okay, our Q's are all of the factors of our leading coefficient. So what are the factors of 3? 1 and 3. Okay, so now we have to find our P's divided by our Q's. So take our first P divided by our first Q. 1 divided by 1 is 1. 1 divided by 3 is 1/3. 2 divided by 1 is 2. And 2 divided by 3 is 2/3. Okay, so there it is. There is our possible real roots. Okay, so those aren't the actual roots, those are just the possibles. 1, -1, positive 1/3, -1/3, positive 2, -2, positive 2/3, -2/3. Okay, so how does this all come into play? We're going to skip example 2 here, we're going to go to example 3. It says find all of the roots of the following polynomial. Now, this is kind of a long process, so you're going to have to bear with me, but this is how you do these problems. Okay, so we're going to do one on the video, and then we're going to do one in class, and hopefully this will make some sense to you. Okay, first step, let's find our real roots, or our possibles. So let's do our p's. P's, remember, are the factors of our constants. What are the factors of 9? 1, 3, and 9. What are the factors of our leading coefficient? Well, it's 1. So what are the factors of 1? 1. Okay. Now, over on the right here, let's do our p's divided by our q's. 1 divided by 1 is 1. 3 divided by 1 is 3. And 9 divided by 1 is 9. So our only possibles are 1, -1, 3, -3, 9, -9. Okay, so put a bar. Okay, let's put a bar down so we can separate our work. And this is how you go about starting the problem. Okay, so bear with me here. I always start with 1. So you're going to put 1 in the box, and you're going to synthetic divide just like we're used to. So I need a 1, a 0, a -10, a 0, and a 9. So 1, placeholder 0, -10, placeholder for 0, 9. And we're going to see if it works. Bring down the 1, multiply, add, multiply, sorry, -9. 0 plus -9 is not -9. 1 times -9 is -9. It works. Okay, so 1, positive 1, I'm going to list them over here, works. Now, you always have to check and make sure that 1 is not a double root. So you have to try 1 again with our new coefficients. 1, 1, -9, -9. We always want to make sure you check for double roots. Okay, so we want to check and make sure it's not a double root. Okay, so let's see here. Bring down the 1, multiply, add, 2, -9 is -7, -7, -9 plus -7 is -16. So is 1 a double root? No, it's not. Okay, so we're going to try to find another one. Okay, we're going to try to find another one. So now let's go to -1. So now we're going to try -1 with our new coefficients. We're still using our new coefficients. 1, 1, -9, -9. We're going to see if this works. 1, -1, 0, 0, -9, 9, 0. Okay, what do you know? So we have 2 roots so far. We know that 1 is a root, and we know that -1 is a root. So let's write down our factors. X minus 1, x plus 1, and then what's left over in our final synthetic division? X squared minus 9. I have that plus x there. Okay, so we could, actually what I'm going to do is I'm going to use that. So plus 0x plus 0x minus 9. Okay, so now let's factor. So we know that this answer is 1, this answer is -1, and now let's factor this. Okay, x. What two numbers multiply to be -9 and add to 0? Multiply to be -9, add to 0. Positive 3, -3. Okay, so now finally, what are our answers? X equals 1, -1, -3, positive 3. So does this one have any imaginary roots? I do not believe it does. Okay, so first thing you're going to do is find your P's and your Q's to find the possibles. Then you're going to start doing synthetic division with all your roots to find a root. We found 1 worked. Then you have to check and see if it's a double. It was not a double because the remainder was not 0, so it was not a double. Then I go to my next root, which is -1. It worked. And then once you're down to an x squared, you can then factor the rest. How else could I do this instead of factoring? You could use the quadratic formula. Okay, so what we're going to do is we're going to do another one of these in class tomorrow, and hopefully after that example it will make much more sense to you. Thanks for watching. Sorry you couldn't see me in this video, but I did make it myself. I will see you tomorrow. Once again, have a good night.